Unit 5, Section 14.2 Worked Examples. Members of the Board of Directors of an association are voting to select a city to host their annual meeting. The board is considering the following cities: City L, City N, and City B. The preference table for the 31 members of the Board of Directors is shown to the right. Show that the Borda Count method violates the majority criterion. There were 31 votes cast. We see that City B received a majority, 16 out of 31, or 52% of the first choice votes cast. Let's see who wins by Borda Count method. First choice is 3 points, second choice 2 points, third choice 1 point. So for City L, for first choice, we see City L has a total of 15 votes times 3 points equals 45 points. For second choice, City L had 16 votes times 2 points, 32 points. And third choice, there were no votes for City L. So the total number of points for City L is 77. For City N, no first place votes. Second choice, 11 votes times 2 is 22 points. Third place, City N has 20 votes times 1 point is 20 points. Total points, 42. And finally, for City B, 16 first place votes times 3 points is 48 points. 4 second choice votes times 2 is 8 points. And for third choice, 11 votes times 1 is 11 points, and the total is 67 points. So the winner is City L by the Borda Count method. Which of the following reasons explains why the Borda Count method violates the majority criterion? Choose the correct answer below. So we can eliminate choices C and D because they don't have the correct winner by Borda Count. We know that we just showed that City L would win, and City L won, but the City B at the beginning up here had the majority of the vote, so the correct answer here is going to be answer A. The administration at a state university is considering 3 possible areas of improvement to their resident halls: parking, security, and lounge areas. The 15 members of the executive committee of the Student Senate rank the choices according to the preference table shown below. Suppose that the Borda Count method is used to determine the winner. Determine if the head-to-head criterion is satisfied. Let's see who wins by Borda Count method. First choice will be worth 3 points, second choice 2 points, and first choice 1 point. So for parking, we see there were 4 votes for first place, times 3 points is 12 points. For second choice, there were 6 total votes, times 2 is 12. And for third choice, there were 5 votes, times 1 is 5. And we go to a total here of 29 points for parking. For security, there were 3 first choice votes, times 3 points is 9. For second choice, there were 4 votes, times 2 is 8. And for third choice, there were 8 votes, times 1, and we get a total of 25 points. And for lounge, there were 8 first choice votes, times 3 is 24 points. For second choice, there were 5 votes, times 2 is 10 points. And for third choice, there were 2 votes, times 1 is 2 points. And the total here is 36 points. So the lounge is the winner by the Borda Count method. Now let's do the head-to-head comparisons. There are 3 choices, so there'll be 3 times 2 divided by 2, or 3 comparisons that we need to make. So let's compare parking to security. So the votes for parking that would come out of this, when we compare parking to security, we would get 4 from column 1 and 4 from column 2 for 8. And then the rest of the votes would go for security. And so parking is going to get the point on this comparison here. Parking versus lounge. Parking gets 4 votes from column 1 and 2 votes from column 2 for a total of 6 votes. And the rest of the votes go to lounge. And so in this case, lounge is going to get the point. And for security versus lounge, security gets 1 vote from column 3 and 2 votes from column 4 for a total of 3 votes. The rest of the votes go for lounge, and lounge gets the point here. So we notice in both cases, lounge won and lounge won. So therefore, is the head-to-head criterion satisfied? And in this case, yes. Suppose the plurality method is used on the following preference table. If B drops out, determine if irrelevant alternatives criterion is satisfied. So there are 16 votes cast. A received the most first choice votes and wins by plurality. So let's remember that. A wins by plurality. And then if B drops out, I've updated the preference table, and you see down here, now A has 7 first choice votes and C has 9, so this time C wins. So is the irrelevant alternatives criterion satisfied in this case? No, because we don't have the same winner. And remember, it says, this criterion says if the candidate is the winner of an election and in a second election one or more of the candidates is removed, the previous winner should still be the winner. And we see that A was not the winner after B dropped out. Suppose plurality with elimination method is used on the following preference table. If 9 voters who voted A, C, B in that order change their votes to C, A, B, determine if the monotonicity criterion is satisfied. So there are a total of 33 votes cast, and we see that A got 11 first choice, B got 10, and C got 12. And so who are we going to eliminate in this first round? We're going to eliminate the candidate with the least votes, which is B. And so here's my updated preference table. So we've got 2 candidates now, and we see now that A has only 2 first place votes, C has 31, so C is going to win. Now in a second election, if the 9 voters who selected A, C, B right here change their votes to C, A, B, then the last 2 columns are actually going to be combined for a total of 21 votes. And so we notice here candidate C is gaining additional first choice votes. Okay, so now what's going to happen on the first round? Who are we going to eliminate? We see A only has 2 votes, so A will be eliminated. And here's my updated preference table. And now we see C has 21 votes and B has 12 votes, so therefore C wins. So is the monotonicity criterion satisfied? And remember what it says, a candidate who wins a first election and then gains additional support without losing any of the original support should also win the second election. And so in this example, the monotonicity criterion is satisfied.